You ever wonder how your phone finishes your sentences? Or how YouTube just knows what video you want to watch next? Well, it's not magic. Not really. It's machine learning. And today, we're going to pull back the curtain and see exactly how it all works. The big question we're tackling is this: how do we get a machine to learn kind of like a human does?
All right, so to even start answering that question, we first have to get a handle on what machines and humans are actually good at. Because as you're about to see, there's this really interesting split in our abilities, and that's exactly where this whole story kicks off.
So check this out. It's really a tale of two different brains, right? On one hand, you've got machines. Give a computer some crazy math problem, done in a flash. Tell it to sift through millions of files, it'll do it in nanoseconds. But then, ask that same super fast computer to do something pretty basic for us, like, drive a car or just have a normal conversation. And suddenly it gets really, really hard for them. And that is the core puzzle machine learning is trying to solve. So you see this gap, right? On one side, you have machines with their insane speed for logic and numbers. And on the other, you've got us, with our knack for handling the messy, unpredictable real world. The entire field of machine learning, it's all about one thing: trying to build a bridge across that gap. Which brings us to the big question that's driving this entire revolution. How do we make computers better at the stuff that's so easy for us, but just ridiculously hard for them?
And believe it or not, the answer is, well, it's kind of simple. The secret is we teach them to learn the same way we do.
So how do we even begin to do that? Well, let's take a look at the OG learning machine, the original and still the best one on the planet, a baby's brain. Because the way a baby learns is surprisingly close to how we teach an AI. See, our brains are just packed with billions of these tiny things called neurons. And every time we learn something, a bunch of them light up and forge connections with each other. The more you do something, the stronger those connections get. Think of it like carving a path in a forest. Okay, let's get real with this. Imagine a baby. They see a big, spotty animal for the very first time. A parent leans over and says, "Look, that's a cow." Zap. In that instant, a specific pathway of neurons fires up in the baby's brain. The next time they see a cow, that same pathway lights up again, only this time it's a little bit stronger, a little more defined. And this is the really important part. As any human knows, learning isn't just about getting it right. It's about making mistakes. Maybe the baby sees a horse and yells cow. When a parent gently corrects them, that neural pathway for cow doesn't just disappear. It gets tweaked, it gets refined. It's this whole cycle of trial, error, and feedback that makes our understanding of the world get better and better. Okay, so that's the blueprint from biology. Now, how in the world do we take that incredible, messy process and translate it into something a computer can use? How do we go from brains to bots? Well, we basically build a digital version of it. We create something called an artificial neural network. It's a computer model made up of artificial neurons and connections that can get stronger or weaker, just like the real ones in our heads. And this is where you get that buzzword you've probably heard 1,000 times: deep learning. All deep learning really is a type of machine learning that uses these huge, layered artificial neural networks. We then feed them massive amounts of data. I'm talking millions of pictures of cows, for example, until the network learns to recognize the patterns all on its own. So just to make sure we've got the terms straight, machine learning is the big overall field. Deep learning is one super powerful tool inside that field, the one that's inspired by the brain. But there are other tools too, like more traditional statistical models. Those are less about mimicking a brain and more about using classic math to find patterns. Think predicting a house price based on its size or forecasting company sales. It's pure, powerful number crunching. Okay, I know this can all sound a little bit out there, a little abstract. But here's the thing. You are already using machine learning all day, every day. You just might not realize it. I mean, think about it. The spam filter in your inbox, that's a machine learning model that's learned from billions of emails what looks like junk and what doesn't. Those eerily accurate video recommendations on YouTube, that's a system that has learned your tastes. And when you talk to Alexa or Google Home, they're constantly learning from you to understand you better. It's everywhere. So yeah, this tech is already woven into our lives, but this is just the beginning, for real. So where is it all headed? What's the next big thing that everyone is racing to figure out? Well, one of the biggest frontiers is driverless cars. I mean, that's kind of the ultimate test, isn't it? It combines recognizing things, making split-second decisions, and dealing with a crazy, unpredictable world.
It's why companies like Tesla, Google, and Uber are investing billions and billions of dollars into getting this right. The payoff could be huge.
And the goal here isn't just to make a car that drives as well as a person. The real goal is to make one that drives better, one that can see more, process information faster, and react quicker than any human ever could, hopefully making our roads a whole lot safer.
So we've gone from teaching a system to recognize a cow all the way to trying to teach it to drive a car. We're teaching machines to see and interact with our world in ways that were pure science fiction not long ago. And it all started by trying to copy the way a tiny baby learns, which really just leaves us with one massive, exciting question. What on earth will they learn to do next?